Hello, my name is Fadila Sartan Adam, NIM 2410110600054. Let me explain about transistor. A transistor is a semiconductor device used to amplify or switch electronic signals in electrical power. It works on the principle of controlling the flow of current through semiconductor materials, typically silicon or germanium, with an electric field. Key principles. 1. Structure. A transistor has three main parts. Emitter, the part that releases carriers, electrons or holes. Base, a thin, middle layer that controls the flow of carriers. Collector, the part that collects the carriers and allows current to flow through the circuit. In the most common type, the bipolar junction transistor, BJT, these parts are configured in two types, NPN and PNP. 2. Operation. Base emitter junction acts as a forward biased diode that allows current to flow when a small voltage is applied. This initiates the flow of carriers. Base collector junction, usually reverse biased and controls the output current flow. In an NPN transistor, a small current at the base allows a larger current to pass from the collector to the emitter. In a PNP transistor, the current flows in the opposite direction. 3. Amplification. The transistor amplifies signals by using a small current input at the base to produce a larger output current at the collector. This characteristic makes transistors essential in amplifiers. 4. Switching. A transistor can act as an electronic switch. When a sufficient voltage is applied to the base, it allows current to flow between the collector and emitter. On state. When the base voltage is absent or below the threshold, it stops the current flow. Off state. Logic gates are the fundamental building blocks of digital circuits, enabling devices to perform logical operations on binary inputs to produce outputs. Every digital device, from the simplest calculators to the most complex computer systems, uses combinations of these gates to execute operations. Here, we'll explore three essential logic gates: NOT, AND, and OR. This comprehensive explanation will cover their functions, internal workings, real-world applications, and their role in complex circuit designs. 1. NOT gate. Inverter. In-depth description: the NOT gate, often called an inverter, is the simplest type of logic gate. It takes a single binary input and produces a single binary output that is the opposite of the input. If the input is logical 1, high, the output is logical 0, low, and vice versa. Symbol, truth table, and Boolean expression. Symbol. The NOT gate is represented by a triangle pointing to the right with a small circle, known as the inversion bubble, at its output. Truth table. Input, A. Output, Q, 01102. And gate comprehensive description: the AND gate is a fundamental logic gate that outputs a 1, high, only when all of its inputs are 1. If any input is 0, the output will be 0. This gate enforces a strict, all conditions must be true, logic. Symbol, truth table, and Boolean expression. Symbol. The symbol for an AND gate is a D-shaped figure with multiple input lines converging into it. Truth table. For a 2-input AND gate. Input A, input B, output Q, 000010100111. 3. OR gate. Detailed description: the OR gate is a basic logic gate that outputs 1, high, if at least one of its inputs is 1. It implements the inclusive, OR, operation, meaning the output is true if any one or more of the inputs are true. Symbol, truth table, and Boolean expression. Symbol. The OR gate symbol resembles an arrowhead with a curved back and converging input lines. Truth table. For a 2-input OR gate. Input A, input B, output Q, 000011101111. Internal structure and circuit design: the OR gate can be constructed using parallel connected transistors. Alternative components. OR gates can also be made with diodes that direct current flow to the output if at least one path is energized. Transistor implementation. When any one of the input transistors receives a high input, it allows current to pass through and sets the output to high. This parallel arrangement means that the circuit output will be high if any one of the input conditions is met.
혹시나 괜찮다면 잠깐 시간 될까 만날 수 있을까 별